Hello students. So we are learning matrix algebra and today we are going to learn about eigenvalues and eigenvectors. How to find if the matrix is given. Okay. So we have to make use of this equation. This comes from the equation Ax equal to lambda x. Okay. So where A is the matrix which is given. Okay. X is the value which is eigenvectors, okay, and lambda are known as eigenvalues. So to find eigenvalues, we have to first make use of the equation which is a characteristic equation A minus lambda I determinant is equal to 0. Then we are going to get this lambda 1, lambda 2 or any number, so that we have to substitute here, okay, and we have to find values of x, that is eigenvectors. So let's solve one example. So let's start with one example. Okay, here I am taking a 2 by 2 matrix. So to find eigenvectors and eigenvalues, first you have to write it in terms of a minus lambda I. This determinant you have to take equal to 0 to find values of lambda. Okay. So this is nothing but lambda is multiplied to the identity matrix of order this, that is 2 by 2. Okay, so this is, if I take a minus lambda I, then this will be 3 4 4 minus 3 minus lambda into 1 0 0 1. Okay, so this is 3 minus lambda 4 4 minus 3 minus lambda. Okay, so this determinant of this, that is a minus lambda I, is you have to put equal to 0. So the equation becomes 3 minus lambda into minus 3 minus lambda minus 16 equal to 0. So this minus you can take outside. So this will be 3 minus lambda, 3 plus lambda. So this is a minus b, a plus b. So you'll get 3 square 9 minus lambda square minus 16 equal to 0. So this is nothing but lambda square minus 9 minus 16 equal to 0, which is lambda square minus 25 equal to 0. So a square minus b square, a minus b, a plus b. So lambda minus 5, lambda plus 5 equal to 0. Okay. So the values of lambda are 5 and minus 5. Okay. So these are eigen values. Now we have to make use of these values to find eigen vectors. Okay. So first I'm taking lambda equal to 5. So put this in the equation a minus lambda I into x equal to 0. Okay. So this we have to write a minus lambda. So a 3 minus 5. So this is minus 2 minus 3 minus 5. So minus 8. X vector is xy. So we have to find values of x and y. Okay. Now to find x and y, you can directly multiply and you will get two equations. Okay, that you can solve, or you can reduce this row so that you will directly get the values of x and y. Okay, so to reduce, I'll reduce means I'll make this row 0. Okay, so 4, so this will be r2 plus 2 into r1, and so this becomes 4 plus 2 into minus 2 minus 4, 4 minus 4 0, minus 8 plus 2 into 4, so 8 0. Okay, so multiplying, you will get the equation as minus 2x plus 4y equal to 0. Okay, so minus 2x is equal to minus 4y, minus minus gets cancelled, x equal to 2y. Okay, so you can put whatever value you want. That is, if you put y equal to 1, so I'll put y equal to 1, so I'll get x equal to 2. Okay, so the eigenvector is 2, 1. Okay, this is related to lambda equal to 5. Now you take lambda equal to minus 5. Okay, so putting this in a minus lambda I and multiplying it with this, we'll get 3 plus 5, 8. So reducing this, we'll get 4. R2 changes to R2. This will be 4 minus 8, you will get minus 4. Okay, 2 minus 4, you will get 2. So this or will take like this. 8x directly you will add plus 4y equal to 0, and second equation is 4x plus 2y equal to 0. Okay, so I'll make use of the adding this two. What you will get? 12x plus 8y equal to 0. Okay, so this is 12x equal to minus 8y, and this is 6. Sorry. So this will be 2x equal to minus y. Okay. Again, you can take the values. If you take x equal to 1, you will get y equal to minus 2. Okay. So the eigenvector is 1 minus 2. Okay. So eigenvalues are here, lambda equal to 5 and minus 5, and eigenvalues are this. Okay, this same method you can use for 3 by 3 matrix. Okay, we will be solving one example on that also.